Hello everyone. So let's start with dynamic programming. So what is dynamic programming? Dynamic programming is nothing but an enhanced form of recursion. So since recursion is really important for dynamic programming, let's understand the intuition behind recursion. Recursion generally works with a top-down approach. So we start with call n-1 and then we move our way down from call n-1, call n-2 to the base case, which is generally call 0, call 1. So let's say in a recursive problem there is only one function that we call. Like, let's say there is a function and within that function we call the same function only once. For example, there is the factorial problem. So in that case, like within fn we call fn-1 and then we call fn-2, like this. So in this kind of a problem there is no repetition, so dynamic programming is not required. But the dynamic programming becomes really important in cases when there is repetition. So let's say when we have like multiple choices and multiple repetition, in that case dynamic programming becomes important. For example, we have the Fibonacci. So let's say we call Fibonacci of n, this is equals to Fibonacci of n-1 plus n-2. So n-1 is n-2 plus n-3. So you see there is a repetition over here. So what if we can store the value of n-2 once we already calculate it and use it again in the next time? So that helps us like saving resources. That is why dynamic programming is really important. Now, in order to optimize the solution, instead of calling the same function with the same parameters, we store the values we already have calculated. So like I was saying, optimized recursion is equal to dynamic programming. So what are the main conditions for dynamic programming? Like, we should have choices available to us. Let's say we can take an element or we can choose not to take an element. Like in such cases, generally dynamic programming is available. And when we have multiple calls, like we saw in the Fibonacci case, like we need to have multiple calls within the same function, multiple calls of the same function within that function. Okay, so now that we know that we need dynamic programming, like we can't just start with the matrix approach. Like I have seen a lot of people directly start with the matrix approach and think of coming to a dynamic programming solution. That is not really very intuitive, because like the matrix is built with the help of a function that we derive from the recursive approach. So the very first step for any dynamic programming problem is building the recursive approach, and then we can think of like using a matrix to store the values that we encounter multiple times and create a dynamic programming based solution. So like the main key point for dynamic programming is we should start with a recursive solution. Okay, then we should use memoization. What is memoization? Memoization is nothing but the same recursive solution where we store the value we calculate once, and after we have done memoization, if you want to enhance the solution further, we can go for the matrix based approach, which is the bottom up approach. It is also called tabulation. So that is what dynamic programming is all about. So now we will be talking about the most important dynamic programming questions. Like, take it from me, in almost 80% of all the interviews that you're going to face, like these are the top 10 types of dynamic programming questions which you are going to encounter. So like I can't exactly say like these are the only 10 questions that you're going to encounter, but every other problem you see in dynamic programming can be derived from the solution of these 10 problems, more or less. So like once we get an understanding of each kind of problems one by one, like we can go on and understand the different kind of variations of these problems. So more or less like these questions and around 6 to 7 or 7 to 8 variations of each of these questions together cover up like the 80% of dynamic programming. So like following up the top 10 questions for dynamic programming, all the other questions are variations of this question. So for that we have 0-1 knapsack, unbounded knapsack, Fibonacci's problem, like longest common subsequence, LCS problem, LIS problem, longest increasing subsequence, cadence algorithm, dynamic programming on trees, dynamic programming on grid, matrix chain based multiplication, matrix chain multiplication and other problem, or like other some miscellaneous problems. So we will be doing each problem in detail, and we will be also doing 6 to 10 like 6 to 7 different kinds of problems followed by these problems. So these questions more or less should cover the main chunk of dynamic programming.